Good evening. Buenas noches. Speed of light. It's all about the speed of light, this one. This absurdity that they're saying is 299,792 kilometers per second is ridiculous. The sun's diameter is 1,390,000 kilometers and the speed of light is 299,792 kilometers per second. If we divide the diameter of the sun by the speed of light, we get the number 4.6. That means it takes 4.6 seconds for the sun to radiate light the distance of its own diameter. I've called it an absurdity. I've called the methods that they've used as absurdities, and it changes everything, right? The sun's light is absolute. Let's just go do one thing real quick before we have a word with Galileo. That's a beautiful moon, by the way. Now, why are we out here? We're out here because we're talking about diameters again. All right. Now, hang on. Right. Now, see that tree? What would be the diameter of the torch bulb that I'm holding in my hand? Look. Did you see how fast? Do you know how far away that is? Do you know how many diameters? The trees, right? Way over the fence, look. Probably. Is it on those clouds? I can see the beam, but I don't know if it's on the clouds right above us. Light. 4.6 seconds per diameter. Are you kidding me? That was about diameters. Some of these torches, right, like a laser. When you look at the diameter, not the distance, the diameter. A sphere is a sphere. So I'm saying that the Google are full of it. What else is there to say? This was about the list, wasn't it? You Google or you search engines and you'll probably find some kind of list, like a speed of light, and there'll be a list of names. Where are they? There they are. There's one of them, and there's the other one. Right, and they're up on that board because I'm convinced that list has changed. We've got Galileo up there, Olaus Roma, Bradley, Wheatston, he's the one that kind of popped out of nowhere, Arago, Armando Fizzo, we know him. Foucault, there's just names on there that didn't make sense, and it triggered this. People saying, nah, you're a fool. Loads of people have worked out the speed of light, have they? Really? None. There's not one logical one out there with the numbers that make sense. The speed of the light from the sun is absolute. Cannot be measured. I said I'd go through the list. I said I'd start at Galileo first. So here we are. Galileo, 1961. It's almost like they introduced him to the world. I had to go through 9 books, so not on this one, but there is at least 10 different spots in the book where Galileo pops up. So this is not in point form, but it is all the info, all the stuff that he has done. Galileo, born in 1564, died in 1642. That's another thing. On the search engine list, they've got Galileo was working out the speed of light in 1667. That's a little bit of a boo-boo, if you ask me. Right. He's classed as the first of the moderns in science. He was all about the evidence, experimentation, measurements, see with his own eyes, right? So legend on that regard. Cathedral, he was at a cathedral and saw a lamp swinging, boom, boom. The pendulum was invented. He ended up working out the pulse. It can be used in, get off! Is that a horse fly? It is. Wasn't a moth, was it? Oh, you look nasty. Where were we? She was, yep, so he invented the pendulum, right? Linked it to medical, and then I think it was Christian Huygens, I think, made it work for clocks, the tick-tock. He was the first to see the moon's surface properly when telescopes came out. He saw the distant stars, so he was the first to say, no, there's more stars behind the stars that we can see in the sky, like the Milky Way, that kind of thing. So he was the first for that. He was the first person to see Saturn's rings. He couldn't work out that they were rings. He didn't know what it was. When the planet was tilting, the rings would go with it. So he thought it was 3 planets, and he never worked it out. Christian Huygens worked it out a few years later. He was heavily into the forces, like Newton's laws of motion. So Newton's laws came from Galileo's stuff. He was actually born on the day Galileo died. He saw the first 4 of Jupiter's moons, Venus's phases. He discovered sunspots along with 3 other people. Shiner, was it Huygens? Oh, I can't remember, 2 other people. Shiner. All right, doesn't matter. With a telescope, I've got a question mark. Sunspots with the telescope. No wonder he went blind. At 25 years old, he was teaching math at Pisa University. He studied projectiles, the way projectiles travel, and that's along with the laws of motion. I got it, died the same year as Newton was born. He studied diffraction when the telescopes came out. When they first came out, he studied diffraction. He made better, improved on everything, and he was selling them and selling other instruments as well. He was the one that worked out that air has weight, and he also dropped different weighted items from the Leaning Tower of Pisa, and it is said that they landed at the same time, and this was to prove that it doesn't matter how much mass or how much weight something is, they drop at the same time, not in the vacuum. He was all about the Copernican system. That means the sun is in the middle and everything goes around it. What was that? Go away. Where were we? Yeah, the sun in the middle. Now, this is important. is pricked up with light. He said that light has a definite speed. He tried, but no, because speed of light was too great to be measured by crude apparatus at his disposal. Right? Now let me get the book out where it says that. Well, I went back and forth with this, I don't know how many times. Right? And once I'd done it all, I wanted to find out where I'd actually forgotten. There's so many pages of Galileo, but it was actually in the same page as Olaus Roma, so I had to find Olaus Roma to find out when that was said. All right, now listen to this. Right, there it is. One of the most significant scientific advances in the 17th century was the realization that light does not travel instantaneously, as had been formerly assumed, but requires time for its propagation. Galileo had advanced the belief that light had a definite velocity, and he had tried to measure it, full stop. But the speed of light was too great to be measured by the crude apparatus at his disposal. And then it goes on to say it was the Danish astronomer Olaus Roma. All right? There is nowhere in any of the 9 books, anywhere where it says Galileo got 2 assistants with 2 lamps 2-3 miles apart, and he was going to try and, as they opened up one lamp and the other one would wave, going, yeah, see, he was going to time it, right? Ridiculous. Alexa, how did Galileo work out the speed of light?
Here's something I found on the web. According to main.edu, Galileo tried to measure the speed of light by placing 2 assistants with lanterns 3 miles apart.
Alexa, did Galileo work the speed of light out?
From usertoday.com. Canelo Alvarez knocked out Sergey Kovalev on Saturday night in the 11th round of their fight in Las Vegas.
Alexa, stop. Alexa, did Galileo work out the speed of light? How did that sound like knockout?
From Fislink.com. Although Galileo was the first person of record to try to determine the speed of light, he was not successful.
Alexa, was Galileo successful at working out the speed of light?
From Fislink.com. Although Galileo was the first person of record to try to determine the speed of light, he was not successful.
She has got one where she says he worked it out. Alexa, what year was it that Galileo worked out the speed of light? What year was it?
From Space.com. The speed of light was first measured to high precision in 1879 by the Michelson-Morley experiment.
That's another one. No, it wasn't. That's an absurdity. God. Right. Where are we? So that's it. And you'll see it's not anywhere else. He learned math and physical science instead of medicine. Right, in 1961, Encyclopedia, the science one, it said he learned math and physical science instead of medicine. Right, just remember that. The telescope helped him differentiate between the stars and planets because they hadn't worked out what was what when the telescope came along. It helped him work out the difference. He saw the difference between the both. He was always in trouble with the church because of what he was saying, and he lectured at Padua University. And Christian Huygens worked the rings out later. That's all 1961, okay? 1966, he designed a sector that aids draftsmen. He played the lute and organ well, became a well-known painter, studied medicine and work of philosopher Aristotle. math and physical science instead of medicine. In 1966 it says he studied medicine and the work of philosopher Aristotle at Pisa University. He worked out the phases of Mars and he worked on the motion, acceleration, gravity, which is the Isaac Newton connection. 1967, 68, the hydrostatic balance came in and magnets popped up. How long is that? That's 7 years. 71, father encouraged him to study medicine, right? That was the only different thing. So 10 years later, math and physical science instead of medicine, but now, father, it's strange. All right, 74, 75, nothing we haven't heard. Let's go over, make sure it's still. So in 1975, he studied medicine and had a private tutor for math. Now, he saw a microscope for the very first time in 1624, and with his ingenuity, he instantly improved it. And he paved the way for Newton. And there was a big write-up about him in trouble with the church. When I say big write-up, I mean big, like dates where he went to trial, this, that, and the other. That's another adventure, that is, because a few of the books have got write-ups like that, and quite in depth. 1979, he won a reputation for his excellent paintings, it is said. But here, it was just became a well-known painter. It's a bit different than won a reputation for his excellent paintings. 1984 just repeats. 1990 and the 1989, he invented a calculating compass for mathematical problems, investigated the strength in materials. Now this, in none of the others, right? And the Copernican theory was the only one that supported his tide theory, which was based on a moving Earth. And again, always in trouble with the church, and another massive write-up. That's in the 1990 World Book. So there we have it, and down there, no speed of light, no lanterns, no assistants, no 2 miles apart. It is not in any of the books, but online they say it happens. So what's what? The books are here, right? Now this is what I'm saying. When they add things, this has been done to make it look like the speed of light was worked out, right? But it hasn't been worked out. Something else I want to quickly point out. Remember freaking Bradley and his stellar aberration? And I said, I've been outside and it cannot be done. I said, it's an absurdity. Right? Well, listen to this, because this is something else. It's also relevant, right? It's just also relevant. So watch. 7224. Right, I've got the book out. 7. Now, because everything to do with light, I had to look to see if I could find Galileo's name, right? And if I find something in one of the other books or as well, I'm going along, I will come back and say, if we find out in here that he did have 2 lanterns and I missed it, I'm not going to say, not say anything. I will put my hand up and say, guys, I missed this, right? But at the moment, no. Right, 2, it's all absurdities. Now, with that aberration, I said, you've got to put yourself in the first person, right? I said, I've been out there loads of times and looked up and done that. How would you even start, right? I call it an absurdity. And I gave him 4 stars, and I said, I'm not going to give him the 5th one because I don't know that much really about stellar aberration. But this is what it says in the book. Right? Popular book of science. Now, if you can see that, we're going to the second paragraph. The study of these motions is one of the most difficult branches of astronomy. There are several reasons for this. In the first place, the distances between stars are so immense that one can make out changes in their relative positions only with the most precise instruments and the most painstaking methods. Another problem is the lack of reliable frame of reference in measuring stellar motion. Since we live on the planet Earth, we have to use it as a reference point. Obviously, it is not very satisfactory for this purpose because it's moving. Not only does it make its annual journey around the sun, but the entire solar system, etc., etc., etc. Which is why I said it's an absurdity. How could he have done it back in 1726 when there was no power? There was nothing, right? There was no instrument to do these things, right? So again, now that's Galileo gone. Remember, he was using a telescope, right? That's the whole thing dead. It's a fact, it's dead. Bradley, stellar aberration, rubbish, right? Absolute rubbish. All of them are going to turn out to be absolute rubbish. It's not been worked out. It has not been worked out. It's lies. It's lies. It's the age of the universe. It's the photos that's being taken by the telescopes telling us that this happened and black holes are chewing on stars 8 billion years ago. It's just this. Right? And the books are telling the story. Right? The books are telling the story. That is Galileo. Now, like I said, there's real good chance that as I'm going along, because I'm going to do Roma now, Olaus Roma is going to be the next one, that he might pop up. And I might have missed something. Like I said, I'm not here to lie, I'm being objective. I'm following the facts, the evidence, right? And if something comes along that makes me change my mind, I will change my mind. Because the evidence, the facts tell me to. That's how it works, right? So, Olaus Roma, he's next, and I'll be quicker this time. I think Galileo, he's a nightmare, because he's everywhere. You see how much he's done? And he taught math at Padua as well. I think he lectured. Honestly, this guy, I don't know. But there is no mention of him and these lanterns. That's a Google thing. That's them making the numbers up so it looks like it happened. Right, Roma's next. Speed of light from the sun is absolute. The stars in the night sky are there as you see them live. No working out of the sun's light has ever been done. It's too fast. See you for Roma time.